Hello, everybody. My name is Alan Garcia. I'm a master's student at the Senior Staff Research Center. Today, I'm going to talk about my research topic entitled Classification of 380 aluminum alloy intermetallics through the use of trainable software. Metallographic inspection has used traditional methods without implementing current technological advances. In the present research, a method is present on which, by means of obtainable software for image classification and segmentation, PG Image J, plugin Weka, micrographs of the 380 aluminum alloy are processed to classify the precipitates present in this alloy, considerably reducing the time required for the usual visual inspection. This poster is divided into three sections: experiments, results, and finally conclusions. In the experiments section, I start with the chemical composition of this alloy. These data were obtained from the literature. The chemical composition obtained has units of present by weight. The composition is as follows: silicon 7.5 to 9.5%, iron 1%, copper 3.4%, manganese 0.5%, magnesium 0.1%, zinc 2.9%, and the ratio of iron to manganese is 31. The alloy was modified using 0.04 weight% strontium for all cases. After knowing the chemical composition, it was decided to perform a design of experiments, adjusting the amount of iron, manganese, copper, and silicon with random values of low, average, and high composition, as shown in the tables on the right. Based on the composition table, each of the sample was processed in induction furnace. The raw material was introduced in the alumina crucible, into which the elements were added one by one until complete integration. The liquid aluminum fired with a rapid propeller to obtain greater homogeneity in the material. In the results and discussion, the results obtained from optical microscopy, SEM, EDX, and the tunable segmentation can be observed. In the optical microscopy, it can be observed how the precipitates can be distinguished by their coloration and morphology. These were studied by the SEM, EDX, with which results were obtained of the atomic percentage of each element analyzed punctually. And when comparing them with the literature, it can be concluded that the precipitates indicate in the micrograph of the SAM, SEM, EDX are thus corresponding to their level. The segmenter can take advantage of type of coloration of each precipitate to identify it with its corresponding level. Each precipitate has a value from 0 to 3, as well as a color that distinguishes. So that when obtained the segmented image, it is possible to know how many pixels there are on each color of each color. In this way, it's possible to know the volume fraction of each element present in the segmented morphographic image. Finally, the conclusion take into account are The method of classifying precipitates in 380 aluminum alloy using the software Imrc plugin Weka was giving effective results. The software can help to obtain volume fraction results to know the percentage of precipitate present in a specific area and to be able to know what chemical properties it represents. The software can be used for quality inspection process, being able to recognize a large amount of micrograph in short period of time.